everybody, welcome back to the channel. It's Mr. G here. As you can see, we're down in the workbench area today and we're going to be working on relays. So I'm going to show you a procedure to test to see if your relays are good or if your relays have gone bad. So stay tuned, we'll be right back. Hey folks, this is Mr. G and welcome to Just Corvette Crazy. On this channel we talk about Corvettes, we fix some Corvettes, and we love to drive our Corvettes. So if you like what you see, hit that subscribe button. It really helps the channel out a lot. Thanks. Alright, we're back. So today what we're going to be doing is some relay testing. So before we get into the relay testing, I'm going to give you a little bit of a background on how a relay works. So there are two major parts to any relay. The first one is what we call the relay coil. The second is a set of contacts. So there's something that's one of the most common types of relays is called a single pole double throw relay, and this is the kind that you're going to see quite a bit in automotive industry. The single pole refers to one input, so a single pole, single input. Double throw means that the input can go to two possible outputs. So there's something that's called the wiper. The wiper is typically spring-loaded. And the way that the single pole double throw relay works is voltage is applied to the coil, creating a magnetic field. The magnetic field attracts the wiper, overpowers the spring, and moves the wiper to the other connection. When we remove the voltage, the magnetic field dies off. The spring then pulls the wiper back to the original condition. There's something that's referred to as normally closed and normally open contacts. The word normally means when I'm not putting a voltage that creates magnetic field, what is the condition of the contact? So if I look at this contact here with the spring pulling, when there's no voltage and no magnetic field, that contact is closed. That one is open. When I apply the voltage, the closed one opens and the open one closes. But the word normally means when the relay is just sitting there with no power to it, what is the condition of the contacts? Are they open or are they closed? So again, if we apply voltage, creates a magnetic field, the magnetic field pulls the wiper to one location. When the magnetic field dies off because we remove the voltage, the spring pulls it back to another location. So what that looks like, I have a little demonstration here. So here is the power coming in. Let's pretend this is the wiper. So the wiper is in one location. The relay is energized, causing the wiper to move to another location. The relay is de-energized. The spring pulls the wiper back to the original location. So normally closed, that one is open. I energize, and then it goes over here. So that's basically the way that the relay works. So what we have, the relay we'll be testing today, is a relay that I took out of the C4 Corvette, so the 1986 Corvette. This is the mass airflow sensor burn-off relay that I replaced, and I'll show you why I replaced it. There are two ways to test any relay. The easiest is if you can actually pull the top off the relay and expose the inner workings. So, like this. So here's the relay. This is the coil. Over here are the contacts. This part here is the movable wiper. You can see if I push it, it moves. This is the wiper. So when the magnetic field is activated, the wiper moves to that location. When the magnetic field is deactivated, the spring, here's your spring, the spring pulls it back to the original location. So in order to test this, what we're going to do is we're going to test the coil. So we're going to put electricity onto the coil and see if the wiper moves. So what I've got is I've got a 12-volt supply, and all I'm going to do is apply my 12 volts to the wires on the coil and see if she clicks. Here we go. You can see that the wiper is actually moving. So the coil is working on this relay. The next thing I want to do is I want to check the contacts. So in order to do that, I require an ohm meter. So this multimeter here, I have it set up as an ohm meter. And I'm going to make a connection that I'm going to test on these contacts. So the wiper is actually this section here. Now, just for test purposes, if I was to make a connection between these two pins, you'll see that the meter goes to 0. Now, my meter has a nice function where it'll beep when I have continuity. Okay, so that beeping noise means there's a connection. So what I'm going to do is I'm going to go from that wiper to the first contact. So this is the normally closed contact over here. You hear the beep? That means that this wiper is now making a good connection over here. If I take my thumb or my screwdriver and I move the wiper, you'll see that the beeping stops. So what I'm doing is I'm physically overpowering the spring and I'm pushing this over to this side. So like that. So now what I'm going to do is I am going to go to the other contact over here, and I'm going to test to see if I can actually get a connection on the other contact. So that other contact is this one here. Now I don't have a small jumper enough to be able to do that for the camera, so I'm just going to go down there. So now basically what I'm going to do is I'm going to close this. So right now that contact is open because the spring is pulling the wiper over to this one. What I'm going to do is I'm going to force this one to close on the other side. You'll notice that I get no beep, or a very faint beep, or a very intermittent beep. So there's no beep. Nope. Oh, a little bit of a beep. That is the sign of a bad contact. So I'm going to change from the beep to resistance. Okay, so you should be able to see that meter. Watch that meter. So I'm going to go here and I'm going to touch this and move it over. Okay, you'll notice that the resistance is fluctuating quite a bit. Okay, if I go to my normally closed contact, it's very steady. So that's the sign of a bad connection on that other contact. Okay, so it's jumping around quite a bit. That's the sign of a bad connection. So what's happening is the connection between the wiper and this point is not a solid connection. It's worn away, it's gotten dirty, corroded, oxidized. Something has happened here. A lot of times these contacts, the coating that is on them burns away and the contacts become very unstable. So this is the reason that I replaced this relay, because these contacts are becoming worn out. So that's the easy way to measure or to determine whether your relay is working. Sometimes you can't get the cover off, and all you're left with is a relay that looks like this, and you've got pins underneath. So just to make this nice and easy, I'm actually going to draw this. There we go. And inside there we have 5 connectors. If you notice, we have 1, 2, 3, 4, 5 connections in our schematic. We have to determine, without being able to see the relay, we have to determine what each one of those are. The first one we're going to be able to find easily, or the first 2, is the coil. So the coil is going to have some kind of resistance to it. So what we're going to do is we're going to take our meter on resistance. So we're going to read something in ohms. And what we're going to do is we are going to go through each of the pins and determine which ones actually have a resistance. And that would be a nice steady resistance. So what I'm going to do, I'm going to take this first lead here and I'm going to put it on pin number 1. Then I'm going to take the next lead and I'm going to put it on pin number 2. You'll notice that the resistance here is open loop. So that means there's no connection between those two. Then I'm going to go over to 3. And then I'm going to go over to 4. Here I'm getting 0 ohms. So that means that that is a short circuit connection, not a resistance that we're looking for of the coil. Then we go over here and 5. Nothing. So we're going to then move this to number 2. And we're going to go 2 to 3. Now if we go 2 to 3, look, we have a steady resistance, almost 60 ohms. That is what we're looking for this coil. A nice steady resistance. Now typically the coil resistances, they can go from 50 ohms upwards to hundreds of ohms. If we were doing this on a coil, like an ignition coil, you're going to get like 1 ohm. But on a relay, there's so many wraps of that small wire. Typically we get somewhere 50 to 900 ohms, give or take, depending on the type of relay and the manufacturer. But here we're getting 60 ohms. So we can conclude that pin 2 and 3, so if we looked at 1, 2, 3, 4, and 5, pin 2 and 3 are for the coil. So now what we have left, so that's this one done, that's this one done. We've got pin 1, 4, and 5. Now we have 3 connections left. We need to know which is which. So here is the test for that. what we're going to do is we're going to take our lead and we're going to put it onto pin number 1. Then we're going to go to pin number 4. Pin number 4 is 0 ohms. So that means that between 1 and 4 is our normally closed connection. So this could be number 1 and this could be number 4. Or this could be number 4 and this could be number 1. We don't know yet. But what we do know is that normally closed connection is between here and here, between 1 and 4. So that makes, by default, that one 5. So what we're going to do is we're going to try and figure out which one of these is 1 and which one is 4. So how do we do that? Well, what we want to do is we want to figure out if this is number 5, so I'm going to put this over under number 5. If this is number 5, when I energize this coil, there's going to be a connection from here to number 5. Now, depending on which pin I'm on, so if I put this on pin 1 and I energize this coil and that connection happens, then I know that this is pin number 1. If I put my black lead on pin number 4 and energize it, and there becomes a connection between 4 and 5, then I know that this is pin number 4. And then we know the other one is the opposite. So what I'm going to do, for fun, I'm going to go 1 to 5. So now 1 to 5, and in order to make this happen, I need to energize my coil. So I'm going to take my 12 volts and I'm going to apply it to the coil. So I'm just going to get a little wire here, just so that I can get inside this relay easier. So now, when I energize this relay, and you'll hear the relay click, watch the needle or watch the meter. So I'm going to do this, energize that, and it went to 0. Now we're getting our fluctuation. Remember, we had a bad connection here, so we're getting some resistance. But you'll notice that it does change. So it's 40, and then it's enough open loop, and then whatever, and then open loop. So what that means is when I energize, this wiper is coming from here to here, and then when I de-energize, it goes back. So that means that pin number 1 is this one, and pin number 4 is this one. If I had pin number 4 here, and I energized it, and I got that changed, then I would know that it was pin number 4. So, what that means is, on the schematic, my coil is between 2 and 3. 1 is the input. And pin number 4 is the normally closed. And pin number 5 is my normally open. So that's what the schematic of that relay would look like. So there's a couple of things that can go wrong with a relay. One is if you get no resistance on anything, then that means that the coil has been burned open. So that means the coil is damaged. Another way is what we're getting is that we're getting poor connection here. So we're getting resistance values that fluctuate when this wiper is moved to that location. Sometimes you can fix this by cleaning it, but normally once the contacts start to go bad, they'll continue to go bad. And the relay should eventually be replaced. The other thing that happens sometimes is that the contacts are damaged so bad that they actually weld themselves together. So therefore, this wiper, when I energize, this wiper does not move. It's welded in place. Or it comes down here and welds to this contact, so when I de-energize, the spring is not strong enough to actually move it back into place. So the coil could fail, or the contacts can fail. But that's a procedure that you can go through for testing a relay to see what the problem might be with your relay. Again, this one is from a C4 Corvette. This is the mass airflow sensor burn-off relay. This particular circuit only uses half of the relay contacts. So it's on or off. So we're not actually using this. So we're not actually using this side. We're only using this side. So it works as an on-off as opposed to electricity going there or electricity going there. But the testing procedure is the same. So that's how you're going to find yourself a faulty relay. A couple of things to look for. So good luck. I hope this helped everybody. And until next time, subscribe to the channel. Stay safe, everybody. Take care.